Welcome, everyone. Thank you so much to everybody who is joining. My name is Jared Duval with Energy Action Network, and really pleased to be joined by EAN's Deputy Director, Kara Robacek, and our four um, great panelists who are looking forward to hearing from today. Our topic, this is the first in a two-part series of webinars focused on heat pumps. The first webinar today is what do we know about heat pump installation and use in Vermont and the region? And then mark your calendars. After this, we will then have part two in the series on Monday, March 30th, which is titled How to Improve Heat Pump Installation and Use in Vermont. So really this is about, on the one hand, starting with taking stock of what we know and what we see in terms of market trends, installation, use, and then also how do we look forward to get as much as we can in terms of pollution reduction and cost reduction from heat pump installation and use. Want to note up front that this presentation is being recorded, as you can see from that red dot up there. And we also, our panelists have graciously agreed to provide their slide decks afterwards. So we will post those to the EAN website at eanvt.org afterwards if you want to rewatch it or catch something that you may have missed. Um, so without further ado, I should one other logistical note, which is there's a lot of really good content that we're looking forward to covering. And we're all in this as an open Zoom meeting rather than a webinar. So just a friendly reminder, it looks like everybody is. Please stay on mute during the presentations. And if you have a question, if you can just jot it down as a note to yourself, and then once each presenter has gone, we'll have some time for Q&A, but I think it can sometimes be distracting for the presenters if we're kind of putting them in the chat as we go. So please definitely make note of the questions and we'll come back to them for a Q&A period at the end. But let's dive in. We're really grateful to all of the folks who've stepped up to join us today and lend their experience and expertise. That's Phil Bickle and Kelly Lucci at Efficiency Vermont, Alec Anchak at the Vermont Public Service Department, and Aaron Cosgrove with Northeast Energy Efficiency Partnership. And they are going to present in that order. So let's go right over to you, Kelly and Phil.
Hi, I'm so glad to be joining you all today. I'm Kelly Lucci. I'm the Director of Strategy and Partnerships for Efficiency Vermont. And today, as Jared mentioned, I will be tag teaming, co-presenting with Phil Bickle, who is the lead for our HVAC programs at EVT. So you'll see us kind of handing off, sharing content a little bit as we go through the slides, but I'm going to kick us off. So the focus of our presentation today is a market assessment that Efficiency Vermont completed related to heat pump usage in Vermont over the last couple of years. And we will also have some content on the next webinar that'll speak a little bit more towards the action plan end of things. So you can go ahead and advance, Cara. First, I just wanted to start with the quick bumper sticker on who Efficiency Vermont is. We are an energy efficiency utility that serves all of the state except for a Burlington Electric Department territory as it relates to electric efficiency. We also provide energy efficiency for unregulated fuels in the state, so the areas outside of Vermont gas territory. We really try to work through sort of a broad effort to transform markets for various energy efficiency technologies in the state. And we do that by working directly with customers, working with the supply chain, working across various aspects of the workforce, and are really proud of what we've been able to achieve over the last 25 years in the state. Next slide, please. So wanted to start with a really quick primer on Vermont's statewide heat pump program, just to ground you all in what it is, how it works, and what we've achieved to this point, as well as just some other pieces of context as you move towards the second part of our presentation here, which will focus more on consumer awareness and attitudes. So first off, as I mentioned before, Efficiency Vermont really focuses on looking at the entire supply chain of a given technology as we implement our programs. And we do this because there's a lot more to an efficiency program typically than just putting out a rebate form on your website and asking customers to fill it out and be reimbursed for their costs. We really have to think right from the level of manufacturers right down to the customer. So what does that mean? It means that we are constantly scanning the market, looking for new and innovative technologies that can help benefit customers and benefit our electric grid and help people reduce their thermal costs. So we began really looking at heat pumps well over a decade ago as their manufacturers began to introduce models that could work in Vermont, in cold climates like Vermont. We started to dig in, understand those technologies, understand how they might be applied here, and we began to work with manufacturers to try to encourage them to bring those to the state. We also simultaneously really looked to develop relationships and engage with the distributors of the technologies and retailers in the state to understand their business practices, what it would take for them to want to stock these technologies and work to promote them to contractors and customers. And we began to understand, what Vermont had in terms of a workforce to actually feel confident and comfortable installing these technologies and providing a good experience for customers. As the program has developed over time, we've been able to really integrate some deep partnerships with electric distribution utilities so we can maximize the benefits for customers and create as simple of a process as possible. And in terms of our engagement with consumers, we really try to provide third-party independent information about these technologies, right? Not everybody is going to benefit from the installation of a heat pump. And it's super important before a customer undertakes that type of a transaction that they understand the costs and benefits and how that's going to work for them so that they can make a really informed decision and feel good about that transaction on the other side. One thing that we are constantly thinking about, especially with integrating new technologies, is if a customer has a bad experience, that can really set back the broader market adoption for technology. It creates a situation where it becomes that much more challenging to get other customers on board. And so we really take that customer experience very seriously and try to build that into how we design and implement our programs. Go to the next slide, Cara. So just a high level on the current structure for this program. As noted here, support for range of heat pump technologies, ducted and ductless. As Phil will share, ductless heat pumps are currently much more widely adopted, sort of further along in customer adoption than ducted technologies, which are a little bit more complicated to install, require a distribution system, and are just not quite as far along. We leverage qualified products lists supported by NEEP and regularly updated to maintain the quality of our program, make sure that we are supporting models that are optimally efficient from an electric usage perspective and will be appropriate for Vermont's cold climate. You can see a few more specifics here, but one thing I want to name as we talk about funding. The way the program operates, as I noted, we work through with a network of distributors and contractors, but we actually issue at point of sale a rebate that combines funding from both Efficiency Vermont and from electric distribution utility partners. And we do this for simplicity and ease for both customers and distributors. So this means that at the time that a heat pump is sold, it is going to have two rebates reflective of it being a more electrically efficient model and also reflective of its intended use to offset fossil fuels as well as frankly, provide more efficient air conditioning as well, because these models, heat pumps can do both, which is great and is a benefit that many consumers are interested in. I will say too, there are, in addition to that sort of point of sale rebate that we operate with those partners, there are bonus rebates that are available through more of a downstream direct to consumer approach. Some of those distribution utility partners administer those directly, and in some cases, Efficiency Vermont administers those on their behalf or in partnership with them, where it would be the case that we would also be offering additional support for those customers. For example, in the case of a bonus for a low and moderate income customer. Phil, did I miss anything that we should highlight from this slide, or do you feel like that covered it?
I think you covered that very well, Kelly. Yeah,
Okay,
thanks.
then, Kara, you can go to the next one.
Right. So I'll take over from here, or on this slide here, just a quick snapshot showing over the past decade the heat pump adoption, starting when we were just focusing on ductless systems in the first once we started with the midstream rebate in 2015, and then we brought on ductless systems a little bit later around that time, but overall, ductless systems. Overall, ductless systems account for nearly 90% of heat pumps that have been installed over time. Yeah, 2019 was the year that we expanded the program to include ducted systems. You can kind of see here that it's more or less leveled off around, between 10 to 12,000, and that's where we have seen one of the limitations is that with our workforce. That's really when our contractors have told us they've been at their busiest over the past several years. That was really around what we're at. So that seems to be kind of what the current workforce in Vermont can do all in 1 year. So we move on to the next slide. Just show some highlights here. The good news about heat pumps is that we've installed more than 82,000 since the program began, about 10% of homes in Vermont. And if we look at the number of single family homes here, that's about 20% of single family homes that have at least one heat pump that's been installed. And that is through the work of over 200 contracting companies that are in our Efficiency Excellence Network that support heat pump installations.
And I'm going to go for a couple slides here, Kara. So as I noted, that's all kind of context on how the program works. Phil and I are really here. The meat of our presentation is to just share some information from you. Basically a decade into this program, recognizing that the Department of Public Service was taking a look at this program as well, and Alec is going to speak to some of their findings. We thought this is a really important time to actually step back, look at the state of the market, understand how customers are viewing this technology, how they're using this technology, and sort of what are some tweaks, improvements we can make to make sure that it is doing what it needs to do for the state and for our energy programs. So next slide, Kara. So just a quick high level of that market assessment, which is, by the way, available on Efficiency Vermont's website. If you are interested in sort of digging into the details, it is a paper that goes much more in depth than what we're going to share today. But the goal was, look comprehensively statewide, understand from a customer perspective, what are some of the barriers to adoption, and what are maybe some levers that we can pull to address those. Focused, as we noted, on cold climate heat pumps. And we also, of note, worked closely with other partners who are engaged in these programs to help inform the findings from this assessment. So that's both the partners in the supply chain who we engage with regularly to implement the program, as well as distribution utility partners who, as I noted, are putting dollars on the table to help support rebates in support of this technology alongside Efficiency Vermont. Next slide, Kara. And I will hand it back to you, Phil, to speak a little bit more about the findings from that assessment.
Sure. So as part of the market assessment, we conducted a survey of residential customers in late 2024. We surveyed customers who installed a heat pump through our program to gauge their satisfaction and usage patterns. We also conducted a series of panel interviews of providers who hadn't installed a heat pump to assess their level of familiarity. The response rate to the email survey was higher than average, so it gave us good solid data to work with. And these results, which I'll get into more detail over the next several slides, indicate some really positive trends along with the areas that we need to address. So the next slide, go through this real quick. Actually, we can more pie chart showing this the breakdown of ducted and ductless. Again, we mentioned earlier that over 90% of installations are ductless heat pumps, and 90% of those are residential installs. So let's jump to the next slide, please. just real quick, showing a breakdown of the awareness. Good news is almost all Vermonters have heard of heat pumps, but the familiarity really varies, and over 50% have don't have are very confident to how well they could speak to explain what a heat pump is. So that's definitely some work that we could do. But next slide, please. I want to first highlight and really stress here that people with a heat pump are having a good experience with it. They may not be utilizing them as much as we'd like to, but if they're already happy with their heat pump, it'll be easier to work with them to influence their behavior to achieve the outcomes that we're looking for. So we can see here 90% satisfaction reported by people who have a heat pump. Of course, 90% of them aren't using them as much as we'd like them to. They're using secondary heating system on very cold days. Air conditioning, as we'll talk a little bit more, is a huge motivator. So let's go back to get the next slide, please, and just talk about some of the challenges to adoption that I'll show a little bit more data on in the next couple of slides. But first, it's probably not a surprise that upfront cost is one of the most cited barriers to adoption. As you can see here, talk a little bit on the next slide, there's other limiting factors to increase adoption. People didn't cite this, but Vermont's aging housing stock is pretty significant when it comes to things that are impacting how we're able to people being able to install heat pump. Most of our homes, over half our homes, were built before 1980. So we all know older homes, they can have challenges with having weatherized as well, and maybe other sorts of upgrades, or just pose a challenge in terms of how one could retrofit the home to a heat pump system. So that's definitely a big factor as well. And we'll talk a little bit more about the other factors here on the next slide. So this is the breakdown and response from the non-heat pump owners, indicating why they aren't likely to install a heat pump any soon. Again, there's this perception that they're too expensive to buy, or people don't have a lot of knowledge. They don't know enough about a heat pump to make it to decide on what to do forward. And then there is the challenge of people may know already that they need to update their electrical system or their electric panel to increase the capacity of the service, or do other home upgrades that are preventing them from taking any action right now. Next slide, please. So what motivates a customer to decide to install the heat pump, and what do non-heat pump owners say will motivate them to move forward? We noted here, like adding air conditioning is a huge motivator. We all know summer times in Vermont, we're getting more periods of very high humidity, several times over the summer, and it really becomes a comfort and also a safety issue for our aging population. So this is definitely something that is, I think we're seeing is pushing people to move forward. But there's also a lot of decision is being pushed by wanting to save money on heating costs, and that's what even people who haven't installed a heat pump yet are thinking about. Or thinking about it. That's what they're citing as well. But what I see is interesting here is that people with heat pumps weren't motivated by their previous system breaking down. Only 10% of respondents noted that. But that's the second most cited reason given by a non-adopter. So 42% of them are saying something that happens to my heating system where I know it's going to break down. That's when I'll move forward. And of course, as we know, a lot of times the heating system is going to break down in the middle of winter, which is, and you need to get it fixed quickly. So that's probably not the best time to start thinking about installing a heat pump. Next slide. Yeah, thanks. And customers indicated here about the performance. All owners use a secondary heating system on very cold days. So this is sort of that breakdown. On the next slide, please. We can get into a little bit more detail here. So here's the temperatures at which people report they turn on their second heating system. And I want to note quickly that all heat pumps that are eligible for our rebates have a minimum coefficient of performance of 1.75 at 5 degrees Fahrenheit. And this means that they're 75 more efficient than electric resistance at that temperature. So even down at very cold temperatures, single digits, which, except for this winter, we don't get for long periods of time like that, a heat pump is going to be pretty well efficient. And it's hard to know if these switchover temperatures are related to the customer's cost of fuel. We don't have that data here. But people most likely do not know that the exact temperature at which it becomes more cost effective to run their boiler or furnace than their heat pump. So there is more education that we could do here. The next slide, Kelly, take over
Yeah,
from
I'll
here.
take it from here. And I'll note too, as a heat pump owner, uh, I tend to make a decision about that set point based on how my back is feeling and whether I feel like bringing in a load of firewood, candidly. So these can be very personal decisions that are not likely to come out in the data. But it is fascinating, I think, to be able to pull back and get this information direct from customers. And as you'll see, it is I think a pretty good corollary to some of the information Alex is going to share, which is more based on AMI data and usage information that the department has been able to gather. I did just want to briefly make a pitch. I'm sure you'll hear more for part 2 of this webinar, where we're going to dive in and speak more to what are we doing with these findings. We took this effort to learn how are we planning to approach some changes over time to our programs such that we can leverage that great foundation and that great work that we've done to build the market to this point and to build trust with customers. What are we going to do with that to try to ensure the program continues to be effective and maximize benefits? So I look forward to seeing you all in part 2 of this webinar. And just a really quick sneak preview, if you go to the next slide, Cara, before I hand it over. Here are some of the initial directional places we plan to go and which we'll speak more to in that webinar. So from Efficiency Vermont's perspective, how do we enhance our consumer education? We've got good trust with customers. We've got good interest from customers. We have a great foundation to build on. How can we build that further so that folks who already have heat pumps are able to optimize their use of them and feel really good about that? And then how do we continue to make sure people who are considering installing heat pumps are doing so in a way that is really informed by the energy goals that they have? Obviously, contractor training is a key component of this. And we are also looking at developing and co-designing a program with other implementers focused on whole home heating and thinking about how we can deliver that in Vermont in a way that really fits with what we're hearing from customers and addresses some of the information we've been able to pull out from all the findings we shared already. And with that, I'm going to step aside and hand it off to the next presenter.
All right. Thanks, Kelly. I'm Alec Anchak. I'm the Director of Energy and Efficiency Resources here at the Department of Public Service. And as Kelly said, this is sort of the AMI / sub-metering component to, or the companion piece to the survey data that EVT just went through. So next slide, please. So the department, does evaluations of various measures and programs. And so heat pumps have been, a major measure that has moved through a number of programs, as Kelly said, both on the tier 3 side, which the distribution utilities, excuse me, sorry. The distribution utilities administer, as well as the cold climate efficiency gains that the EEUs administer. And so looking at that holistically, we, went out and found, I think, 3,500 participants, past program participants, and looked at AMI usage to kind of bin them, and then actually went and put sub-meters on a sample population of those units to actually not have to rely on AMI disag or any of that, but actually get direct demand usage from the units themselves. And so, as has been said, I'm sure this is not a surprise at this point, but we're seeing a little bit less usage on the heating side than what we have predicted, about a 30% less. And I think that that's averaged across the state. I think in places like, some of the VIPSA territories, places where maybe some of the housing stock is a little bit less up to date on weatherization or of an older vintage, that number is a little bit higher. And in places like Burlington or other areas where customers have access to natural gas, for example, that number's a little bit lower. And so it's not a uniform thing across the state, but in general, the trend is that the usage is lower on the heating side. And then conversely, on the cooling side, we're seeing a much more usage than we anticipated. And that is both due to just increased usage, but also we noticed that a majority of systems are larger than I think we would have expected, given the energy intensity, based on square footage and nameplate efficiency and sizing of legacy heating equipment, et cetera. And so that suggests that, to Kelly's point, these things are really good air conditioners. They're extremely efficient at that. And so, that may be one of the key drivers in people getting heat pumps, and maybe the offset in thermal loads on the heating side is maybe less of a priority. And then the third thing that we found is that we've also done some market study with that, and basically, the system costs have gone up significantly. This is all based on the technical reference manual characterization that these programs rely on. That's admittedly was a little bit out of date. We also had the COVID pandemic happen between the last time this measure was characterized and now. And so it's understandable that market conditions have changed quite a bit, as well as usage patterns. And so, the bottom line is that given all of the changes in what we expected to see, from the department's perspective, since we are concerned primarily with the ratepayer perspective, there is some concern that some of these units have some are still cost effective, some have fallen below the line on cost effectiveness. And so our concern really was driven by making sure that as we move forward, that we continue to incentivize these things and push them into the market in a way that is still returning on the ratepayer dollars. And so I think that will be covered much more in the second webinar. Next slide, please. So just to sort of set the stakes for what we're talking about here, this is just cold climate heat pumps. This is ductless mini splits that we're talking about. And in general, this is, as I said, this is a pretty major measure in the context of the sort of utility retail programs in the state. We move anywhere from 10 to 15,000 of these a year. Just in the last 2 years alone, you can see we've done something like 23,000 of them at an investment all in of about $162 million. So significant expenditure on the part of the state, and that's all theoretically being precipitated by these programs. And so important to keep it in that context. But just to sort of put that in perspective of what's at stake, heat pumps are an incredibly important measure for these programs, both for the renewable energy standard goals that are set out through the different tiers, of which it's the sort of the primary tier 3 measure that the distribution utilities to meet their renewable energy credit retirement requirements. And also in the context of the Global Warming Solutions Act, most of the potential analysis that the department has done, that Agency of Natural Resources has done, really relies, any pathway forward to meeting the GWSA targets leans very heavily on ductless heat pumps. And so again, just setting the stakes, very important that we understand this and get this right. Next slide, please. So I think the key points, I think I've already kind of hit on this from a high level, but the key points that we've found in this analysis, and I'll show some of the actual data in a second here, but as I said, we're seeing much larger systems than I think we would have anticipated. On average, a 17% increase in the average system size versus what we would have predicted given the thermal need. And I think that's largely, again, in future data, I can highlight this, but that's largely being driven by the cooling need more than we think it is being driven by the heating need. And then to that point, again, we're seeing about a 54% reduction in total heating usage compared to what the sort of TRM characterization would suggest we would expect. There are a number of reasons for that, some of which we've tested for, some of which are more qualitative, which I could talk about if folks want to, and I'm sure Kelly has some thoughts there too. And then again, we're seeing more cooling usage, about over 100% increase in the total cooling usage we would have expected. And so that reduction in total heating usage, again, because of, we're talking two different input heating fuel types, in terms of the actual GHG savings and the fossil fuel offset, that translates to about a 33% reduction in the total fuel savings that we would have expected. Next slide, please. So here's just more of the stats on how the study was sort of set up, some of the input parameters. This gets into how the technical reference manual characterization is affected. This is getting down into the weeds a little bit, but for folks that are interested or want to follow along, basically, there's as I said, we started doing cold climate heat pumps, well over 10 years ago in Vermont, and we have evaluated them once previously, where at that time we also found that they weren't being utilized quite as much as we would have thought. Potentially some early adopters, people that were a little bit more enthusiastic or understood how to use them better, or maybe were more bought in on the heating offset portion. You can see it was lower than we thought, but it was still significantly higher than what we found in this last study. And so I think as they've proliferated and the cooling proposition, which to be fair in Vermont is more of a concern than it was probably even 10 years ago, that seems to be driving more of the adoption as of late anyway. And so you can see that borne out. You've got the rated capacity jump from, a 17 kBTU up to over 20, which is a significant size increase. And that puts you into a different compressor size, different air handler sizes. So there's a cost implication there too. And then you've got the full load hours on the heating side, which is basically the total number of hours across the heating season you'd expect this thing to run. And you can see a pretty drastic reduction in that from the 2017 study to this past study. And then similarly on the cooling hours, you can see a pretty drastic jump up. And then that we've got the translation into the fuel offset in terms of MMBTU per year. And again, that's averaged across the various fuel types. And so it's not really apples to apples necessarily, but in aggregate, that's generally what we're looking at. Next slide. So getting into some of the data, I think you can, I'll try to get through this quickly and as painlessly as possible. But basically, we're looking at pre and post installation, and then you've got the impact of just the delta between the two seasonal usages, and then you've got the base of what you would have expected. So you can see the post installation, the kWh has gone up. People are using them, but in terms of the impact of what we would have expected, there is that delta there. So again, just another way of representing the data to show that the expected impact is less than we thought it would be. Next slide, please. So here you've got, again, this is just the scatter plot of the average daily temperature, the average daily kWh plotted throughout the year. Average temperature will be the next one, but you can see, there's the market increase in kWh consumption pre and post installation. It's distributed more or less as you'd expect in terms of the heating offset, and you can see on the next slide it'll correlate that with temperature. But again, the line of where we would have expected this plot to be is much further up in that graph than what you're seeing here. Next slide, please. So again, you're seeing sort of the sweet spot of usage, and I think Kelly kind of alluded to this. It's more or less what people reported in terms of the survey results, but you're seeing that, as you get down to around the 30-degree range, you kind of run out of the efficiency sweet spot for the heat pump where the coefficient of performance starts to drop pretty low, and then eventually just gets to 1. And you can see there's people just aren't using them once that happens. And then similarly, as you get up into the higher temperature ranges, the usage increases as well. So more or less what we would have expected, but again, if you compare that with you plot that sort of against the previous slide, it's just not as much as we would have expected, given the ability for heat pumps to offset. Next slide, please. Oh, right, I took the last one out. So anyway, that's basic run through of the data. And I think we're saving questions to the end, but I'm happy to dig in more, particularly on the data side if folks have questions.
Thanks, Alec. Over to you, Erin.
Great, thank you. So hello, everyone. My name is Erin Cosgrove. I'm the Director of Policy and Programs for Northeast Energy Efficiency Partnerships, and very excited to be talking to a group of Vermonters about heat pumps today. Since Kelly already noted it, I'll note that I'm a Vermonter that also uses heat pumps. And then I also happen to live with someone that's part of the Efficiency Excellence Network and installs heat pumps across the state. So I get to live and breathe this program all the time. But today I'm going to be providing a regional overview of the heat pump market, some context on what we're seeing in other New England states throughout the region and how they're installing heat pumps, and then just a little preview of what we see on the horizon, which I bet will be dived into even more next week. So next slide, please. So first, just a little preview of what Northeast Energy Efficiency Partnerships is. We are a regional energy efficiency organization. I like to say we sit between the federal government and the states, and we operate in the Northeast. So I work from West Virginia all the way up to Maine, and we really just help drive regional collaboration and best practices in energy efficiency. So the Northeast and Mid-Atlantic can lower energy bills, reduce air and carbon pollution, create jobs, and improve energy and climate resilience. And also, as noted earlier, we make the cold climate heat pump list that many states in our region use to certify that heat pumps work in cold climates. Next slide, please. So to kick us off, first, I just wanted to give a high-level overview of the heat pump market, kind of on a regional basis, but then pushing out nationally. So as you can see on the slide, air source heat pumps for space heating have increased their market share consistently across the 3 years that our study looked at, which was 2021 to 2023, despite the fact that HVAC sales have actually decreased both at a national level and a regional level. So, and then if you zoom in a little bit specifically in the Northeast, annual sales of air source heat pumps from 2021 to 2023 have increased about 12%, so 25 to 32%. And from the report, our qualitative data and sort of the rebate trends from programs have suggested that it's actually market actors in the NEEP region that are influencing this uptick that we've seen in the Northeast. So high level takeaway from this slide is the heat pump programs in the Northeast are working, and they're really helping to increase adoption. Next slide. So, and then I also just kind of wanted to touch on how much it does cost to install a heat pump system, because I think a lot of this conversation will be talking about rebates and what they look like. So as you can see, this slide here goes through a whole home central ducted heat pump, which has an average cost of between $18,000 and $22,000, and then a whole home ductless heat pump, which can range from $14,000 to $20,000. And then you can also do a partial replacement, which is on the bottom, and that can range from $7,000 to $8,000. And just for some points of reference for everyone on the call, boilers can range from propane or oil can range between $6,000 to $11,000. Gas furnaces can cost between $4,000 to $9,000, and electric baseboard heat costs between $1,000 to $3,000. So installation costs, heat pumps are slightly more expensive than the next best thing. But later in the presentation, I'm going to take a look at operational costs, which is, I think, another big key point and why we should be really looking at heat pump adoption in the region. But next slide, please. So moving on to the next part, just a regional heat pump program summary or snapshot. So just as an overview, all states in New England offer heat pump rebates. The market rate incentives, which I'll focus on for this presentation, vary between $240 to $10,000 per residence, and states offer them either on a per unit or a per ton basis, depending on their programs. And another thing I'll dive into in future slides is we're seeing these rebates really increase to encourage whole home replacement. So partial programs have been successful, but now states really want to see, as we've talked about on this webinar, heat pumps used all the time in the winter. Programs are also offering both midstream and downstream rebates, recognizing the importance of engagement with contractors and distributors to move the market. Another highlight is weatherization is really seen as a key tool for states to ensure comfort and affordability. And I'll go into this a little bit more on another slide. But what we're really seeing is weatherization is a priority for states with natural gas because there's a concern about operational costs with heat pumps raising bills. So a lot of states are starting to either emphasize or require it more. And then also most New England states, all but New Hampshire, have a workforce development network as a key touch point with the industry. And I would say Vermont's really stands out as one of the better ones that have a lot of constant contact with their contractors. And Massachusetts, in their most recent plan, has even elevated and created a second tier that more so mimics what we're seeing in Vermont and Maine, who I think have very strong workforce programs. Next slide, please. Okay, and as I said, I'm going to just talk about weatherization briefly. Jared mentioned the slides will be available after, so I encourage everyone to take a look at this slide if you're curious about how states are tying together weatherization with heat pump installation. But what we're seeing is sort of three types of programs. Programs can require weatherization, and this is Massachusetts and New York have both decided in the next year that they will be requiring a home is weatherized before residents are able to access a whole home rebate. Another way that states have decided to tie the two together is creating a bonus. So you can either receive a $500 to $1,000 bonus on a heat pump or weatherization if you do them within a certain time frame of each other. And then the other step we're seeing is information sharing. So just making sure if a home does get a heat pump rebate, they get some kind of ad or mail piece in the mail saying, you got a heat pump, have you thought about weatherizing your home? We offer a great weatherization program. And I'll just also say again, a lot of the states requiring weatherization are states with high levels of natural gas because of that operational cost issue. But states that are more similarly situated to Vermont, like Maine, which is highlighted, are still kind of relying on information sharing and recognizing that it's important to get heat pumps in a home. And then after that, talk to the homeowner about weatherization. Next slide, please. Great. And going back to Alex's presentation on usage patterns, I wanted to talk about two studies, and I apologize now for all of the content on this slide, but my hope is that you might not need to crack open one of these studies to read it later. Instead, you can use this slide as a reference point. But I'm going to talk about two studies that have come out recently. The first is Maine. So Maine did an assessment of their whole home heat pump program in 2026. And actually, Efficiency Maine Trust evaluated heat pumps in 2021 and 2022 and found that they were underutilized. So as a response, they retooled their whole program to prioritize whole home installs. And they saw usage increase. So right now, they're requiring installations cover 80% or more of heating load in homes. And so this newest study found that whole home heat pumps were operating closer to their full capacity and displacing significantly more fossil fuel. And that is the pie chart to the right here. So all homes in the study saw 64% heat pump usage and 24% central fossil system usage. And then if they remove the bottom 10 performance homes that infrequently use their heat pumps, they saw that there was a 73% heat pump usage and a 17% central fossil usage. So it's just an example for Vermont to look to that other states have also seen low usage levels and have then found ways to retool their programs in order to increase usage. And then the next study on this slide is something from Massachusetts and Connecticut, who conducted a heat pump metering study in 2021 to 2022. For this study, it's important to recognize that Massachusetts and Connecticut both had requirements that heat pumps were sized to fit the whole home. In Massachusetts, they were required to also disconnect their heating equipment. I'll make a note that Massachusetts doesn't require that anymore. Instead, they have the customer go through steps to just make sure they're only using it as a backup. And then in Connecticut, customers were required to install integrated controls, so a thermostat that would switch from a heat pump to a backup system or remove the equipment. But what they did see from these studies is there was full displacement. Almost all heating load was displaced, and this is 86% for ducted and 92% for ductless. And then for partial installation, more than half of the heating load was displaced at 67% for ducted and 79% for ductless. And the slides will be available after, and there's hyperlinks in them for anyone that's curious to learn a little bit more about these programs. Next slide, please. Okay, and then to wrap up, I just want to give a preview of what we're seeing on the horizon for slides or for heat pumps coming up. So these are policies and programs advancing heat pump deployment throughout the whole region. So first, as I mentioned, we're seeing an increase in incentives to prioritize full replacement. So in Massachusetts, they define whole home as 90 to 120% of heating load and provide per ton rebates to design systems to meet that load. In New York, their program is requiring 100 to 120% of heating load, and they're also providing per ton rebates. And then Maine, who I believe will be talking more about their program next week, they define whole home as 80% or more of heating load, and they provide per unit rebates. So states just are right now definitely increasing their rebates, but doing it on a per ton or a per unit rebate basis. Another thing that we're seeing in the region is a really big increased focus on workforce training and installer network engagement, focusing on best practices for installation and sizing. Heat pumps are different than old school HVAC systems. They require sizing that contractors might not be doing at this moment in time, and that might need a little bit more detail orientation. And also their installation is different. So a lot of states are focusing on webinars and discounts for tools to help contractors perform better. Another thing that we're seeing is continuing both midstream and downstream rebates to engage consumers and align the supply chain. And on the regional level, we're seeing a new program will be coming out or is out now, the New England Heat Pump Accelerator. And that is a 5-state effort to do midstream rebates and pair them with the consumer-facing rebates that we're seeing in other New England states. And I'm sure that'll get talked about a little bit more next week, but wanted to put a plug and preview in. And then my last 2 points are another thing we're seeing is adjustments to rate design to promote demand reduction and align with adoption of new technologies. Massachusetts has implemented heat pump rates specifically because they recognize they have climate goals and they want to make heat pumps affordable. And then in Maine, they're looking at default time of use rates. These would apply to all ratepayers, but have actually been shown to lower operating costs for heat pump users specifically. And then a final point is we're seeing a lot of states try to prioritize delivered fuels and electric resistance customers as heat pumps have lower operational costs than those 2 types of systems. And to finish up, next slide, please. I wanted to just give a preview of the operational costs that heat pumps do provide, because it is, I think, really where heat pumps shine is the fact that outside of natural gas, they can really lower winter energy bills. And we are running a little out of time, so I'll pause for questions. But as Jared said, the slide deck will be available, and I encourage anyone to take a look at this calculator that Efficiency Maine Trust has out that provides operational cost price points for different types of heating systems. And that concludes my presentation. Happy to answer any questions.
Thanks so much, Aaron and Alec and Kelly and Phil. That was great. Such a wealth of information. Invite folks who have questions to go ahead now and put them in the chat. We've got 10 minutes for those. While we wait for those, I might just ask a question of all of you, and maybe I'll start with you, Alec, on this, which is this important distinction between the technical capabilities of heat pumps versus the usage patterns. And I think, one of the really important things I'm taking away from the Public Service Department evaluation is that what you were finding wasn't about the technical limits of the technology. It was really about how they were being used. And so it gets interesting when we look at what Aaron was sharing around the region. It seems that there are a number of states that are looking at addressing the kind of lower usage patterns than we would want to see with ductless systems by moving to more of a focus on whole home systems. But there's potentially also this approach, which is how do we improve that usage through some of the things that Kelly was talking about with customer education and working with contractors. And so I just wonder about that balance, and if you can speak more to that key difference
Yeah.
between capability and usage, and what that then leads, some of the questions and opportunities that leads to.
Yeah, it's absolutely correct. That it's the sort of double-edged sword of the split system, right? Is that it's incredibly modular and scalable, and so there really is no limit to the configurations that you could come up with to try to do an offset, which is what makes them really great, right? Because you can do one room, you can do your whole house, and it's infinitely scalable that way. But the flip side is like you could just do one room, and if that room is not the same room that has your zonal thermostat for your heating system, for example, then those two things might be working against each other, right? Or if you can get away with putting a slightly bigger one in your bedroom, but then you open your bedroom door and try to cool the entire second floor of your house with the one air handler that's in your bedroom, then you're going to way overtax the system for, you might get better efficiency gains if you actually just put two air handlers in and put in a smaller compressor, for example. So, yeah, and it also speaks to just the difficulty in general of sort of that matchup of we have, if you're the primarily hydronic sort of zonal systems where you've got baseboard or maybe sometimes they are forced air, but when you're looking at a system like that has your house broken up into like 2 or 3 zones, and then you have this much more scalable solution that can go room by room, it's very important to be cognizant of that as you're trying to scale that one to one.
Kelly or Phil or Aaron, anything that you'd want to add to that? And then we'll go to some of the next questions.
I mean, I think Alec covered it really well. I would just say like that is like as we as we think about the different sort of measures that might be applicable to a residential customer, it's a really important way that this differs from something like weatherization, which is like your home's weatherized. It is comprehensively good. You're good to go. It's going to benefit you no matter how you choose to use it. If you're increasing your thermostat, you're going to pay more. I think this is an area where it really does benefit to have built that trust with customers and to have sort of that foundational engagement throughout the supply chain, because that means that we recognize if people aren't using these in the way that could benefit them the most, we have the opportunity then to kind of layer in that information and try to build a pivot that makes sure that people are making the choices that are the best for them. I know when I don't use my wood stove, it may cost me a little bit more, but my back feels better, right? I'm making that choice intentionally. We want to make sure all customers have the opportunity to do that.
So the first question, and there's a clarifying question in the chat that if you didn't see, you may be interested to look at, Aaron. But I think the first question for the group is from Jacob Flanagan, And I don't see Jacob on, so I'll just read his question, which is, do any of you know if the adoption of heat pumps have triggered a discernible rise in winter or summer peak electricity usage in the state? I will say I'm aware that Velco is now working on their next long range transmission plan, and I know is looking into some of these questions. So I'm looking forward to seeing some of that information. But Alec, do you want to speak to that?
I mean, the short answer is yes. Again, it's a bit of a tricky question because of the way that RNS peak shaving kind of works, and there's this sort of shell game that happens with inside Velco. But yes, I mean, I think in aggregate there is increased demand, and it's attributable directly to heat pumps, particularly winter demand.
Yeah, and I'll just add what we're seeing is a number of states are assuming they're going to hit a winter peak probably after 2030. And that's also some states have started. That's why some states have really focused in on weatherization. Other states are trying to see if there's alternatives to lower both the general demand that'll happen in the winter and the peaks.
Great. Thanks, Aaron. So the next question I see is from Alexis, and I don't see Alexis on video, so I'll just repeat this question, which Alexis notes may be best for Kelly, but anyone, please chip in. Is there any difference in the type of rebates available for heat pump adoption in new construction as opposed to replacing an existing system?
Yeah, so new construction is actually a great application for heat pumps, just to name it. It's cost effective to install it at that time. It can be integrated in the design of the home. It just provides a lot of options for folks. Just want to name that's a very positive application. And the way to think about it is our midstream rebate that I talked about, that applies to any unit that's being purchased in the state that meets our qualified product list and goes through one of our distributors. So that would apply whether the heat pump is being installed at the time that a home is newly constructed, or whether it's being installed later on because somebody's changing out a heating system. So the rebate in that case is the same. I do just want to note that Efficiency Vermont has a new construction program that provides per unit incentives for multifamily properties, and also an approach and kind of engagement in the supply chain on the single family side. So there would be other incentives that somebody could take advantage of at the time of new construction. We do try to encourage, support, and engage with folks to encourage, where it is appropriate, all electric new construction as well.
As a participant in that program, I can say I have a fully electrified home, very much thanks to Efficiency Vermont. So it's really there.
I also saw earlier, not to put you on the spot if you've changed your mind, Representative Pouch, but I saw that you had your hand up if you want to go ahead and ask your question. I didn't see it in the chat.
Oh, yeah. Thanks. And maybe you've answered it. I'm not quite sure. We're talking about utilization. As the temperature gets colder, there's less utilization. Is that from people just turning on their boiler and turning off their heat pump? And because, in my mind, we put in heat pumps at the church. And, the question was, and there's a backup furnace. And they said, well, the question was, well, when should we turn on the furnace? And I sort of said, if it feels cold, otherwise just keep the heat pumps going. And I do the same at my house. I have a choice of an electric boiler that can do a little backup, or just the heat pumps. And, in my mind, it got -10 or -15. I was like, maybe I should change over. I'm not sure. So just some guidance on that. And is that what, is it people just making that choice individually when to switch?
Jared, do you want me to respond to this, and then if others want to jump in? Okay. So I would say it is people making that choice individually, kind of based on their own individual factors largely. Like, I don't know that there's like some kind of a silver bullet takeaway that says this is, the distinction between folks. I will say, one thing that we do whenever we have a heat pump sold, we try to send out some educational materials. I think the guide is called 8 ways not to use a heat pump, right? Where we kind of encourage folks to think about winter usage because it's more efficient when it is being run continuously. We talk about, sort of how you can optimize for comfort. You pick your temperature setting and then you adjust the fan. It's more efficient at higher fan speeds. All of this type of context that might be a little bit different for somebody who is new to the technology. So we try to kind of give people that context and that information. And then I think as we're kind of doing engagement and reaching out to customers, we really do find that individual situations just vary significantly. You've heard me give my example already. I'll say like another flip of that coin that is probably different for me than for others. We installed our heat pump because cooling wasn't possible in our house without a heat pump. We have casement windows. We knew our home was pretty tight, and we knew summers were getting hotter and hotter. So we installed it, really excited about the air conditioning benefits. And then also, because I work where I work, I knew it could be a great solution for us in the winter too. So we, worked with our contractor to size it and site it so it could be used effectively in both cases. And I think there's an opportunity here to just continue kind of investing in that engagement with contractors and engagement with customers so that they have the ability to make those individuals choices that might be best for them depending on what their goals are, but make sure that those are informed choices and that as much as possible, we're giving people the opportunity to optimize for their costs at an individual level and to optimize for the costs we're all going to share as participants in a broader electric grid. So that's how we kind of think about this. But I will say, based on the research that we've done, it is clear that, people have very kind of custom individual scenarios that they encounter in their home that might inform that choice.
Could I just add one other point to that is I think from a cost perspective, I guess, because you're right, Kelly, like there are a lot of different factors that go into how and why you might choose to supplement with your heat pump. And it's a different kind of heat. It's, forced air versus hydronic. It can feel very different. It can move around your house very differently. So there's a lot of factors that are important to consider. But I think from a cost perspective, there is sort of an efficiency curve that heat pumps operate on. And once you get below like 30-ish, 25, 30 degrees, the coefficient of performance of a heat pump drops to basically 1-to-1. And at that point, it becomes probably more expensive than most fossil sources to heat your home with. Again, also a lot of factors that go into that cost equation. And so depending on what your input fuel type is, depending on what the combustion appliance is, if it's a forced air furnace, if it's running natural gas, or it's a hydronic system that runs on propane or something, it can be very different. And so that cutoff point may or may not be less or more cost efficient from an operations perspective. But it is important to remember that below that point, the heat pump is really just kind of 1-to-1 in terms of the BTUs it's moving from outside to inside. Whereas above that temperature, that's where the heat pumps really see the efficiency gains and become very cost efficient to run because they're running at, upwards of a 3-to-1 ratio in terms of the BTUs they can deliver inside versus the input energy to move them. So just another data point.
And I'll just add very quickly. I think Massachusetts is one state that's had switchover temperatures, and it was a study from a few years ago where, and I'm just going to give ranges because I can't remember exactly, but I believe for natural gas switchover based on cost, it was between 40 and 30 degrees. Oil was more in the teens or the single digits, and then propane was actually at like -10, -15, just because of how much it costs
Just
to upkeep.
ridiculously expensive. Yeah.
Well, I want to thank everybody for joining us today, and all of our panelists. A reminder that this information will be available on EAN's website at eanvt.org. If you've registered for this webinar, you'll get an email with a link once it's up, and the slides will be there as well. There's a lot more to discuss. I'm sorry we didn't get to all of the questions in the chat, but hopefully that just whets your appetite for part 2 of this series. Please do register and join and plan to join us on March 30th at noon for part two, how to improve heat pump installation and use in Vermont. Thank you so much, everybody, and have a great afternoon and weekend.